welcome to Ladyada.
Hey everybody, and welcome to Desk Ladyada. We've got a couple things to show off today. We got a little bit of mailbag, and we got this funky thing that Mr. Ladyada got for me. But first up, is there any news or updates you want to let people know?
Nope, full speed ahead. Take it away, Desk of Ladyada.
Okay, well, let's go to the overhead. Okay, so first up, you've got this
yeah, it was some
weird
Arduino. Yeah, I collect pink PCBs, and this is one that arrived in the mail.
Yeah,
and it's has open source hardware logo. It's called Arduino Uno.
I wonder if the files are actually.
Well, I don't believe so.
Yeah,
and it shows up as like an Arduino in the Arduino IDE.
Yeah, it's got like a standard USB serial converter. It got some extras. It's got like an on-off switch or some switch. It's got an extra button. It's got, looks like, pin protection on some GPIO or something. It's wider than most Arduinos, so that's something to watch out for. 2 NeoPixels, it looks like, an old buzzer. So,
this one's going in the Arduino museum that I have of all sorts of weird Arduinos.
This is like the demo, so it kind of does some stuff.
That's cool.
I don't know what that... Oh, it looks like there's LEDs over here.
Hey, look at that.
Yeah, I don't know what's up with that. And then this is... I don't know what this is either. Looks like it's got a demo. Anyways, funky. I like, the silk screen's interesting. It's like, how do you do this kind of detailed silk screen is kind of neat.
Yeah.
So, I don't know.
So, that'll be part of the Arduino Museum.
Yeah.
It is now added to the collection.
You like to collect the weird ones, for sure. All right, next up is you got this Spaceball 2000. What's the story with this?
This is when we were on a good track on what the internet was going to be and what computing could be. So this was an input device that you often use for like 3D modeling and more. I saw this probably in a lot of like 90s movies, but this was it's haptic-ish. So when you hold the ball and move it around, that would rotate models in space and more. And then you had these like quick keys up at the top, and turn it over to the side if you want. It's beautiful. Like this is definitely when you're doing things like the Lawnmower Man, prop.
Yeah.
Crew. It definitely looks like something out of that. So we took some photos of it because we wanted to have our gallery of interesting input devices. But then I said, hey, Ladyada, could you get this to work with like a regular computer, like a modern computer?
Yeah.
And we were testing some samples and doing some other things, and you said, yeah, matter of fact, I can.
Yeah, because I had this sample that I got. This is a DE9 connector. This is serial, because mice used to be serial only. And so I had a sample that's a USB-C to serial adapter cable, and I was like, I have to test it anyways, and so, why not test it with this? So this adapter plugs into a computer, and it gives you a serial port, but then the output voltage is plus or minus 6 to 10 volts instead of like 0 to 3 volts. Like most people are used to, console cables like this, and this kind of console cable, has power ground RX-TX, and the voltage on the RX and TX lines is about 3 volts, whereas the voltage, the power is maybe, 3 or 5. Whereas on RS-232 serial, it's plus or minus, and it's inverted. So it's like what would normally be, a high level, like 3.3 volts, is actually -6. So it's like inverted, and it's also this wide voltage swing. And that's because, this is a non-differential signal, and this was meant to go long distances. And so to deal with the resistance of the cables, they would just have a really wide voltage range. And so as the cable got farther and farther, it would shrink down, but it would still be, plus or minus some voltage. And then, there are people who've made they've sort of turned these, I guess there's a modern version. So this is the 2003, even though this was like a 1990s thing. And the the 2003 version, like I said, it doesn't have USB. It has serial, and there's people who have written code that will convert this into like an HID device, but it got like the code looked very complicated. And so I wanted to start with just, can I read the data and what's the data format? So let's go to the computer, and then this is a nice document written by LabTech. I guess it's published by them, or I don't know, unclear. And they published the protocol, and so it's RS-232C, 9600 baud, 8N1. There is X on X off flow control, but luckily I haven't seen it. There's, I guess, data is coming through the USB serial port fast enough, maybe it did happen, but I just end up dropping the data that doesn't pass the structure. And then there's packets, and then there's like request packets, and basically you send data back and forth, binary data, and there's a little bit of encoding, and for the most part you can there's some data that's sent asynchronously. So when you press a button, a packet is sent. So it's actually a good way to test it. As you press the little buttons at the top, data packet is sent, and then the other thing you can do is query it. You can ask it which buttons are pressed and what is the location of the ball, and it will send you a packet in response. So it's you kind of want to do both. I like to poll for the ball location, and then I listen for asynchronous data to get the button presses. So I kind of went through. I didn't really read through all of this because it's kind of long. I just wanted to get like the basics going. There's also a buzzer inside that you can beep, and there's like help and data packets and error packets. But basically, I put together a quick script with pySerial, which is like a great, it's Python. I find is really good for this kind of stuff where you're sending and receiving data, and it can be binary, and you have to pack it and unpack it. This is the mask, the binary mask for each button. So each button, it sends back 16 bits of data, and each bit indicates one button. There's 9 buttons. There's 8 at the top, and there's 1 in the ball itself, which is kind of weird. There's like a little belly button on it. And I keep track of the states, and then I've got a serial port. Lines are read. All data packets end with a /R or /N. So that's really easy. You init by just telling it, hey, send me binary data. And then I just have a loop where I look for K packets, which is the button data, or D packets. So I'll uncomment the part where I actually show what is being read. And I can, hold on. Is that readable?
Yeah.
Okay. Yeah. So when you press a button, you see I'm getting these packets that start with K, and the bits, the 2 characters afterwards are affected by which buttons I'm pressed. I'm pressing, so if I press more buttons, and I touched the ball, sorry. So if it's just the buttons, you get a K packet. And then D packets are when you move the ball around, so you can see it starts with a D, and then it has 2 bytes of like timestamp data, and then 6 sets of int 16, 2 byte per data point for X, Y, and Z. Oh, sorry. When I click, I forget that pauses the output. And then you can see, I'm parsing the data into the X, Y, and Z, and it always ends up with 0, 0. Like if you release it, always go back to 0, 0. So like that's another way you can test that you're getting the data right. But as I'm moving the ball, maybe I'll hold this up. As I'm moving it, data comes through, and then I press buttons. I get button presses. So that's it. I mean, pretty much, it's the code's done. I mean, it's again, there's existing projects out there that interface with the Spaceball 2003, but they're more complicated, and they use like USB IP, and it was kind of like a big thing, and they try to implement the HID interface so that it can act as an HID device. But I was thinking it'd be more interesting if this was connected to like a Featherwing or something. Because then we can make a Bluetooth version of this. The only other thing to watch out for is the, there's this cable which is serial and power, and the power needs a 2.5 millimeter jack, not 2.1 millimeter. FYI.
All right.
All right. Any questions or?
No, I think we might put up a little video, or if you want to toss the code up or something like that, we can do a little video.
Yeah, I can toss the code up on a gist or something.
Okay.
It's not like a whole thing, right? But
Yeah.
It's
Let's do it. Let's do a gist so we can get the gist of it.
Okay.
And then what's the great search this week?
Okay, so the great search is I wanted to make a Featherwing that would connect to this, and so
let's play the song,
do the song,
and then we'll do it.
Yeah.
Where in the world is that part I need? The great search with DigiKey.
The Great Search brought to you by Ladyada, Ada for DigiKey. Thank you so much, DigiKey, for supporting the Great Search. Ladyada, use your powers of engineering every single week to show people how they can find things. Sometimes it's stuff in the middle of a project and you're like, oh, this would be a good Great Search. So this week is what?
Okay, so this week we're working on integrating this Spaceball 2003, this 3D mouse thing, and it comes with a DE9, which has RS-232 serial on it. And I realized that we don't have a breakout in the Adafruit shop, or I don't have one, that will convert TTL serial, like from an Arduino or CircuitPython board, whatever, into RS-232. And so I thought, let's go to DigiKey and see if we can find one that does that. So this is, just quickly, this is the protocol for the Spaceball 2003. And at the bottom, I think there's even a little pinout diagram. Maybe I'm confused. Maybe it was another document. Sorry. So this was only the protocol, but there is a pinout, and basically it's plus minus 6 volts on the data line, and so I need to convert 0 to 3 volts to 0 to -6 to 6. So let's go to DigiKey, and so what I want is an RS-232. They're called transceivers, which I always misspell. So let's see if I got it right. Yeah, not I before E. I guess it's except after C. That's true. So it's CEIVERS. And so these are chips that will convert logic level to RS-232 standard. And one of the nice things about these, it's one of the first chips I actually used in school, is that they'll also, not only do the level conversion for you, but they'll do the level generation for you. So you don't have to provide them with that negative plus minus 6 to 10 volts. They'll generate that for you using a switch cap converter. So let's go to an active, and then we only want a transceiver. We don't want a driver receiver. We want both receiving and transmitting. Wow, there's an AppleTalk converter. It's handy. Let's go with stuff that's only in stock and only sold by DigiKey. Next question is how many drivers, receivers? So you'll see it's a transceiver, so it's always positive. In general, you want two, so you have RX and TX, that's one set. And then you have RTS and DTR both ways, so it's 4 total signals. But, I'm okay with more, so I'll go up to 4 driver transceivers. And then, let's see. I want only surface mount, because I want to be able to pick and place this. And next up is the voltage supply. Again, there are some here you see that require you to provide it with that plus or minus 7, volts or whatever, 5 volts. I don't want to do that. I want to run this off of 3 volt logic. So I'm going to select only this and below. So only these, because they will have support for 3 volt power supply and logic, like on the Featherwings. Okay, so lots of options here, but let's do it by, price, because why not? So let's put in, quantity of 250. And then let's see what we've got. So the Max 3232, so originally this was called the Max 232. which is a classic transceiver. The Max 3232, I think, is the 3-volt version. And you can see they're not very expensive, and they come in a lot of different makers. So you see TI makes a Max 3232, and so does Max Linear. They make an SP 3232. So, and there's a lot that are very similar. Like you'll see the SP, and then there's another Max. Renaissance has an ICL 3232. So, and they're all pin compatible too. There's like 16 TSOP and 20 SOIC. So I have a couple options. So basically, anytime you see the 3232, like, down here, there's one. These are good to go. So let's look at this one because this is nice and inexpensive. It's only 67 cents. We can look up the data sheet here, which I already pulled up. So this is a 3-volt to 5.5 volt multi-channel RS-232 driver and receiver. So yeah, it's got these simple buffers, except there's 2 of each. So you get each direction 2 sets. So RX and TX, and then RTS and CTS. So flow control basically, as well as data. And then it comes in a couple different packages, all 16 pins. And then there's this charge pump built in, which is quite handy. And so they mention it, you'll need to add a couple capacitors. There was one Maxim chip I remember that I really liked using in school, back when I didn't have to worry about the price of things because the lab paid for chips. And I would use the one that had the built-in capacitors, and it was like literally it would just be a dip chip, and inside they had the capacitors bonded into the chip. But for a surface mount, if I'm going to be pick and placing it, it's the chip was much more expensive. It was like $5. So again, I have this one chip that I would take with me from project to project because I didn't have to wire up these caps. But if you're making a product, you're probably happy to put the capacitors on, and they even give you a little layout here. So you see there's 2 sets of, there's actually 4 capacitors you need, or 5 if you include the VCC bypass. One doubles the voltage from 3 to 6, or from 5 to 10, and then the other one is an inverter. You can use a switch cap as an inverter, and that gives you the negative voltage. And then the buffer is just powered by these switch cap rail generators. So you can see here what it looks like. There's data in, and then it gets converted from these little 0 to 3 volt lines to this plus or minus red line. But these are very handy. This is a bread and butter chip. It's in stock. If this particular model isn't available, there's always others. So, well, I haven't used this particular one. I have used the 232 series, and they work really, really well for the job. So, this is my pick for the great search.
That's a great search.
Where in the world is that part I need? The great search with DigiKey.
Okay, let's go to a few questions.
Sure.
First up, question, I'm curious about supervisor ICs. How important is the threshold voltage? I was using 2.5 volt one, but I can't seem to find any, but I did order some 2.2 volt ones for a TFT controller. Will that affect things badly?
I don't know. I mean, you're going to have to try it and find out. Shouldn't matter too much. A lot of supervisors have pretty long delays. As long as your power supply comes up pretty fast, any cutoff is good.
Okay. How does one use CircuitPython's UART to transmit with even parity? I can't seem to find what value to use in the parity argument for bus IO. .UART.
Yeah, for that you might want to post in the CircuitPython Discord because I don't have it off. I don't know off the top of my head. I don't know that we support even in every build. We kind of focus on the one that, what everyone uses, which is 8N1. I know 7EN comes up once in a while, but I haven't used it myself.
Any plans for digital signal processing?
You can't get DSP chips now even if you wanted them.
There is that.
That's true.
Okay.
Yeah, that's why I don't do the great search finding FPGAs. People keep asking me to find them FPGAs, and I'm like, you can't.
Yeah, so lots of folks seem to have had the Spaceball, They were saying it'd be good for a space program controller, air traffic controller simulations.
Yeah, these are
And,
adorable. And then I guess how much was the version with the serial port cheaper than the USB version? I mean,
No.
originally these were very expensive. They were like over $1,000.
Yeah, this wasn't. This was just like an eBay find.
Yeah.
I think I had a.
Like a couple $100 or something. I mean, you can still use them.
Yeah, I think I had a RSS eBay feed, and I
Yeah.
just found one for like, here's a bunch of junk in a box, and I think it was one of them.
Yeah. All right. Well, it works. Now we know.
Yep. Okay.
They're kind of indestructible, to be honest.
Yeah. So we'll put up a little video and probably the gist, so if someone wants to check out how we did that,
Okay.
we'll do that soon. And that is tonight's Desk of Ladyada.
All right. Thanks, everybody.
Thanks, everybody. We'll see you next week.